Hello students, I'm Shubhashish. Previously, you've learned about different types of expressions and types of algebraic expressions. Today, in this part, we are going to see the addition, subtraction and multiplication of algebraic expressions. After the completion of this lesson, you will be able to know learning objectives, addition of algebraic expressions, subtraction of algebraic expressions, multiplication of algebraic expressions. Keywords from this lesson: algebraic expressions, constant, variable, coefficient, monomials, binomials, trinomials, polynomials. Addition of algebraic expressions. While adding algebraic expressions, we collect the terms and add them. The sum of several like terms is the like term whose coefficient is the sum of the coefficient of these like terms. The simplest expressions are monomials. They consist of only one term. Example: add 8x and 6x. (8x plus 6x) is equal to 8 into x plus 6 into x. (8 plus 6 into x), which is equal to 14 into x, which gives us 14x. The sum of two or more like terms is a like term with a numerical coefficient equal to the sum of the numerical coefficients of all the like terms. Example: add 8x and 6y. So when we add 8x plus 6y, which equals 8 into x plus 6 into y, simplifying it, here we don't have a common term, so we write 8x plus 6y. Unlike terms cannot be added the way like terms are added. To add two algebraic expressions, we collect different groups of like terms and find the sum of like terms in each group. Add 8x square minus 5xy plus 3y square, 2xy minus 6y square plus 3x square, and y square plus xy minus 6x square. First, arrange the given expressions in descending powers of x with like terms below each other. Then add column wise. 8x square minus 5xy plus 3y square. First, we write that down. and then we write 3x square plus 2xy minus 6y square. And then we write minus 6x square plus xy plus y square. As said, now we add every expression column wise. So the first column, after addition we get 5x square. In the second column we get minus 2xy. And the third column, after adding, we get minus 2y square. Subtraction of algebraic expressions. While subtracting algebraic expressions, arrange the terms of the given expressions in the same order. Write the given expressions in two rows in such a way that the like terms occur one below the other, keeping the expression to be subtracted in the second row. Change the sign of each term in the lower row from plus to minus and from minus to plus. With new signs of the terms of the lower row, add column wise. The simple expressions are monomials. They consist of only one term. Example: subtract 8x from 16x. We write down 16x minus 8x. Simplifying it, we get 16 into x minus 8 into x. We pull out the common factor x, we get 16 minus 8 into x, where after subtracting 16 minus 8 we get 8. After multiplying 8 into x we get 8x. Example: subtract 8y from 16x. We write down 16x minus 8y. After simplifying it, we get 16 into x minus 8 into y. Here we do not have any common terms. So 16x minus 8y. The difference between two like terms is a like term with a numerical coefficient equal to the difference between the numerical coefficients of the two like terms. Unlike terms cannot be subtracted the way like terms are subtracted. Now subtract 3x square minus 6x minus 4 from 5 plus x minus 2x square. Arranging the terms of the given expression in descending powers of x and then subtracting column wise. We write down minus 2x square plus x plus 5, and then right beneath that we write 3x square minus 6x minus 4. Like told, we subtract all the expressions, minus, plus and plus. So after subtracting, minus into minus gives us plus. We get minus 5x square. Here we multiply plus into plus. We get 7x. The same is applied over here as well. Plus into plus, which gives us 9. So the equation we get is multiplications of algebraic expressions. Let us have a look at the rules of sign and laws of exponents, which will be useful for the multiplication of two algebraic expressions. The product of two factors with like signs is positive and the product of two factors with unlike signs is negative. Plus into minus is equal to minus. Plus into plus is equal to plus. Minus into plus is equal to minus. Minus into minus is equal to plus. If x is any variable, m and n are positive integers, then x to the power of m into x to the power of n is equal to x to the power of m plus n. For example, x to the power of 3 into x to the power of 5 is equal to x to the power of 3 plus 5, which is equal to x to the power of 8. Multiplication of two monomials. When we multiply constants as we multiply rational numbers and multiply the same variables by using laws of exponents. Product of two monomials is equal to product of their numerical coefficients into product of their variable parts. Example: find the product of 3ab and 5b. We write 3ab into 5b is equal to 3ab into 5 into b. (3ab into b into 5). By commutativity of multiplication, we can write 5 into b is equal to b into 5. 3ab into b into 5. By associativity of multiplication, we can write 3ab is equal to 3a into b. 3a into b into 5. 3a into b into 5. By commutativity, we can write 3a into b as 3a into b into b. 3a into b, we get b square into 5. 3a into b square into 5. 3ab square into 5. We write now 3 into 5 into ab square by commutativity law. 3 into 5 into ab square again is written as by commutativity law. After multiplying, we get 15 ab square. We have the following two rules for the multiplication of two monomials. First one, the coefficient of the product of two monomials is equal to the product of their coefficients. Second, the variable part in the product of two monomials is equal to the product of the variable parts in the given monomials. So these two rules are also applicable to the product of three or more monomials. Example: find the product of 5xy and minus 7x square y cube. We write down 5xy into minus 7x square y cube. This we can write it down as 5 into minus 7 into xy into x square y cube. Multiplying numbers, so we get minus 35 into xy into x square y cube. Add all powers of the variables x and y, we get minus 35 into x to the power of 1 plus 2 into y to the power of 1 plus 3. We get this because the bases are equal, so the powers are to be added. Next, we get minus 35 x cubed y to the power of 4. Multiplying a monomial by a binomial. Multiplying the monomial by each term of the binomial using the distributive law. A into B plus C is equal to A into B plus A into C. Example: find the product 5a square b square of 3a square minus 4ab. We write down 5a square b square of 3a square minus 4ab. After separating, we get 5a square b square 3a square plus 5a square b square of minus 4ab. Multiplying the numbers, we get 15 into a to the power of 2 plus 2 b square minus, multiplying the numbers again, we get 20 into a to the power of 2 plus 1 into b to the power of 2 plus 1. A to the power of 4 b to the power of 2 minus 20 a to the power of 3 b to the power of 3. Multiplying a monomial by a trinomial. Multiplying the monomial by each term of the trinomial using the distributive law, which is a into b plus c plus d is equal to a into b plus a into c plus a into d. Example: find the product 5a square b square of 3a square minus 4ab plus 6b square. Solution: 5a square b square of 3a square minus 4ab plus 6b square, we can write it down as multiplying the numbers 5 into 3 a square b square 3a square plus 5a square b square of minus 4ab plus 5a square b square into 6b square. Equals to, we get 15a to the power of 2 plus 2 b square minus 20a to the power of 2 plus 1 into b to the power of 2 plus 1 plus 30a square b to the power of 2 plus 2. After simplifying, we get 15 a to the power of 4 b to the power of 2 minus 20 a to the power of 3 b to the power of 3 plus 30 a to the power of 2 b to the power of 4. Multiplying a binomial by a binomial. Suppose a plus b and c plus d are two binomials. We may find their product as given below. a plus b into c plus d is equal to a into c plus d plus b into c plus d. Is equal to a into c plus a into d plus b into c plus b into d. Simplifying, we get AC plus AD plus BC plus BD. Example, find the product 3x plus 5y into 5x minus 7y. Solution, 3x plus 5y into 5x minus 7y. After writing down, we simplify 3x into 5x minus 7y plus 5y into 5x minus 7y. After multiplying, we get 3x into 5x plus 3x into minus 7y plus 5y into 5x plus 5y into minus 7y. We multiply and we get 15x to the power of 1 plus 1. Bases are equal, powers are to be added. Minus 21xy plus 25xy. Plus into minus, we get minus 35y to the power of 1 plus 1. Again, bases are equal, powers are to be added. So after simplifying, we get 15x square plus 4xy minus 35y square. Multiplying a binomial by a trinomial. In this type of multiplication, we multiply each of the 3 terms in the trinomial by each of the 2 terms in the binomial, and we get 3 into 2 is equal to 6 terms, which may reduce to 5 or less. Example, find the product of 2x minus 3 into 5x square minus 6x plus 9. Solution, 2x minus 3 into 5x square minus 6x plus 9 is equal to, we multiply 2x into 5x square minus 6x plus 9 minus we multiply 3 into 5x square minus 6x plus 9. We multiply the numbers 2 into 5, which gives us 10, and x to the power of 1 plus 2, where bases are equal, powers are to be added. Minus, multiplying the numbers again, we get 2 into 6, which is 12, into x to the power of 1 plus 1, plus, multiplying the numbers 2 into 9, we get 18, into x, minus, multiplying the numbers minus 3 into 5 gives us 15x square. 3 into 6 gives us 18x, plus 3 into 9 gives us 27. X to the power of 3 minus 12x to the power of 2 plus 18x minus 15x square minus into minus gives us plus 18x plus 27. 10x cube minus 12x square plus 18x minus 15x square plus 18x minus 27. By cancelling, we get (10x cube minus 12x square minus 15x square plus 18x plus 18x minus 27. Therefore, we get 10x cube minus 27x square plus 36x minus 27. Points to remember. A monomial is an algebraic expression that has only one non-zero term. A binomial is an algebraic expression that has two non-zero terms. A trinomial is an algebraic expression that has three non-zero terms. A polynomial is an algebraic expression that has one, two or more terms. While adding algebraic expressions, we collect the like terms and add them. The difference between two like terms is a like term with a numerical coefficient equal to the difference between the numerical coefficients of the two like terms. Thank you for watching.